Hello once again. In this video, we're going to be solving equations and inequalities in one variable. I should say variable instead of variables there. But we're going to focus on exponential equations and inequalities. Now, I could have just titled this solving equations and inequalities in one variable, but that's something that you think of as linear equations and things like that. And we're really going to be going a step above that and doing it with exponential equations and inequalities in this video. So, first, let's review some things that we've learned previously. So what I call the golden rule of algebra, that's just simply a way of saying what you do to one side, you have to do to the other side. And uh, that's just something you have to do to make sure that you do not change anything in the equation. So anything's legal as long as you do it to both sides. I tell some students you have to be fair. So what you do to one side, you have to do to the other. When we say one side and the other, we mean on one side of the equal sign and on the other side of the equal sign, or inequality if you're doing an inequality. Exponential growth and decay, that's the things that look like you have some amount and it's equal to the principal times 1 plus or minus the rate for the time. This is if you're dealing with money. The generic form for exponential growth and decay is your function is equal to some number times some other number raised to an exponent. And b can either be a growth if it's above 1 or a decay if it's between 0 and 1. Now, in solving inequalities, they're exactly like solving equations with one special rule. Okay, the special rule for solving inequalities is if you multiply or divide by a negative, you're going to flip or change the sign. When I say sign there, I mean the inequality sign. So if it was less than, it becomes greater than. If it was less than or equal to, it becomes less than or equal to. Sorry, my arrow distracted me. It was so bad. Let me take my time a little bit more. So if it was uh, greater than, it becomes less than. If it's less than, it becomes greater than. Blah, 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 blah. All right, so let's get down to the brass tacks here. Now, in solving exponentials, we have to use the inverse. So this is just kind of a review of the inverse operations leading up to what we're doing to undo exponents. The inverse of adding, to undo adding, you subtract. To undo multiplying, you divide. To undo squaring something, you take the square root. To undo distribution, you factor, which is what we did in the last unit. And so to undo raising something to an exponent, you take what's called a logarithm. Now, as inverse operations, these things work both ways. To undo subtraction, you do addition, and so on and so forth. So it does work both ways here. So we're focusing on the exponent part. So we got to figure out what is a logarithm. I don't know if you've ever heard that before. You're probably shaking your head no if you're in my class. If you're just watching this video, then you may have heard of it before, and if so, good for you. We're going to be talking about it right now. So a logarithm is the value to which a number or term must be raised to produce another given value. So here is an exponential form of something. So it's an exponential equation here. And then to go from an exponential to a logarithm, or a logarithmic function, this is saying 2 to the what number is 8. So this right here was originally our exponent. This was the base. Okay, and then this was just the number that we were trying to get. The 3 here is actually what we call the logarithm. and you see where it comes from? It's the value which we raised 2 to get 8. Now in this course, this Math 2 course, we're only going to be using the common log, which is the log base 10. You just write it as log. It's kind of like if you see just a radical sign, this is the square root, and you know your index is 2, even if it's not there. It's not going to be the cube root, because this one, we use a whole lot more than this one, so that one's the one that we know if we just see that sign. So base 10 is so common in logarithms that we just write it log. There's another one that you'll learn that's really common in Math 3, but this is as far as we're going to go in Math 2, is just using common logarithms. Now, there are some properties of logarithms that you'll learn in Math 3. For Math 2, though, we only use one, and this is called the power property of logarithms. The power property just says that if you have the log of some number that's raised to an exponent, you can take that exponent and put it out front and multiply by it. So if we have the log of 2 to the x power, we can take that x out front, and there we go. This property is helpful if you're solving equations, and I'm going to show you an example in just a minute. Actually, right now, after we go over the steps. So, in order to solve an exponential equation, the first thing you got to do is get the term with the exponent by itself. It's kind of like if you're going to take the square root of a squared part, you don't want to take the square root of something that's not squared, because then you still have that radical. So we're going to get the term with the exponent by itself. That way we don't have to worry about something getting caught in the logarithm that's not supposed to be there. So step 2 is then to take the log of both sides. Step 3 is to use that power property that we just talked about to get x out of the exponent. And then step 4, you should now be able to solve for x using your other methods that you've learned in previous classes. So let's do an example. All right, so in this example, I kind of combined a logarithmic example with a word problem. So right here we get a little bit of a double dose. We want to have $15,000 to buy a new motorcycle, but we don't care enough about it to actually work for it and save every month. We've just somehow come up with $1,000 that we want to just put in a savings account with 6% annual interest and leave it, not do anything to it. So how long until we have enough money to buy our motorcycle? Well, using the formula for the exponential amount that we know, we want $15,000 in the end. That's the amount we want. Our principal, or our starting amount, is $1,000. And our interest rate is 6%, so the growth factor is going to be 1.06. Okay, and I'm going to let this be x instead of, well, let's let it be t. T is fine. Okay, we're trying to figure out the time that's going to take us to get this amount of money. Now, I could take the log of both sides, but then this 1,000 would be caught up in it, and I couldn't use my power property because the 1,000 is not being raised to the t power. So the first thing I have to do is get this term by itself. Now, the way I explain solving equations right off the bat is undoing my order of operations in the reverse order, undoing them in reverse order. So the first thing I would undo would be addition and subtraction, and then I would undo multiplication and division, then I would undo exponents. All right, so I want to undo this multiplication first by dividing both sides by 1,000. All right, and so I get 15 is equal to 1.06 to the t power. Now what I want to do is I want to take the log of both sides. This is log base 10, it's the common log. And you notice I make my L's loopy. That's so you don't confuse them with a 1. All right, so now I'm going to use my power property to bring this t out to the front. So I still have log of 15 on this side. On this side, I'm now going to have t times the log of 1.06. From here on out, I just solve it like any other equation. I'm going to divide, since I'm multiplying by the log of 1.06, to undo that, I divide by the log of 1.06. It's just a number. There's actually a button on your calculator that will let you do that. So I get the log of 15 divided by the log of 1.06. Now, if this was the old days before calculators, you'd have to look up uh, this value in log tables and then calculate it by hand. Fortunately for us, we have technology. We have calculators. So, and the calculators pretty much just have the tables for us. It looks it up for us and it makes it quicker. Now, the log button is right here. Let me get us the highlighter here. Is the log button's right here beside the 7. So you'd press it, put in 15, close your parentheses, divided by, and press it again, 1.06, close it and press enter. And it tells us it's going to take us 46.475 years, or about 47 years. Well, 46, well, yeah, it's going to be in the 46th year. So if it's only once per year, it's going to be after 47 years. That's how much time it's going to take us to get this motorcycle if we don't do anything. Alright, so that's my example. If you have any questions on this video, just feel free to post a comment, and I hope you have a good one.